So, welcome back to another episode of the Web3 Insights podcast. I'm your host, Aaron Hayhurst. And also a massive welcome back to Grigore Rosu, who is the president and CEO of Pi Squared. Today, we're going to dive into a major milestone that the team is preparing to announce. FastSet achieving 100,000 plus transactions per second and Sub-100ms for Finality. We're going to unpack how it's possible, what it means for blockchain performance, and also what's next for Testnet this year. Grigore, welcome back.
Thank you for having me, Aaron. Always a pleasure.
Pleasure as always. The last time we spoke, we had a fabulous conversation. You shared your vision for solving fragmentation in blockchain infrastructure. What has Pi Squared achieved with FastSet since then?
Right. So just as a reminder, the way we approach the problem of fragmentation in blockchain infrastructure was through unifying all programming languages under the universal field of mathematics through what we call formal semantics, one of the oldest fields in computer science. Okay, so once you have a formal semantics of a programming language, you can reduce computation to mathematical proof. And now you can verify that mathematical proof with a circuit, zero-knowledge circuit, and you get verifiable computing universally for all programming languages. And this way, thanks to mathematics, which is composable and interoperable by construction, now we can have interoperability and composability of programs in all programming languages. And then all we need to do now is to deploy these computations on chain. And what happened was that we realized that the way to do it, after we spoke last time, is to go through blockchains. Suppose that you have something which is true, right, a computation, and you want to store it permanently on chain. What you have to do is to submit a transaction, stay in line. That's very important because that's what happens on chains. You have a total order. You have to stay in line until your transaction comes, to order, and then it is settled. And we realize that that's not scalable. That cannot be the future of Web3.
Yeah.
We are very close to the point where we'll have millions of transactions per second generated by AI agents, by humans all over. If Web3 is here to stay, then blockchains as are today are not the answer. So that's why we came up with an alternative that allows infinite scalability, theoretically infinite scalability, that we call FastSet.
Amazing. You're preparing to announce performance results, 100,000 TPS and Finality under 100 milliseconds. Can you walk us through how FastSet accomplishes this level of throughput and speed?
Yeah, so first of all, I want to mention that these numbers are not even theoretically possible for blockchains. Maybe pushing the envelope a lot, we can go to 100, a little bit more. On blockchains, everything is just perfect. So first of all, and the most important thing to understand is that in order to get to these numbers, we had to give up the fundamental concept of blockchain. Okay? And let me tell you what that means. So blockchain is a chain in which transactions are organized in blocks, right? That's the name, blockchain. But the chaining part is a problem, total ordering. So all nodes on the network have to agree on a total order on events. So there is a lot of communication going on, the consensus protocols. They have to decide exactly what's the order so that every single node sees exactly the same thing. This is a well-known problem, actually, in distributed systems. And it is well known that this concept, which is called strong consistency, comes with scalability problems. So we actually gave up completely strong consistency and thus the entire philosophy of having a total order on transactions. And once you give that up, once you realize that the total order is not necessary, then you can do things, settlement, in parallel on validators. Okay, so imagine that you save your hash and I save my hash. Right? We can do this in parallel. That means that we can submit these two transactions. Hey, I want to save my hash 1 and you want to save your hash 2. We submit it to the validators, and validators may receive these transactions in different orders. It doesn't matter. Once they settle your transaction and my transaction, they will get exactly the same state. Okay? So what blockchains do, they say, let's enforce a total order, and then everybody will have the same state because everybody executes the same total order.
Mm-hmm.
But there is another way to get the same state, because that's what we need, the same state, not the total order. Total order implies same state. But we can have same state without total order. So FastSet came up with a novel concept of independence. We call it weak independence between transactions. So we very quickly analyze the transactions. Actually, we enforce it. We enforce transactions submitted by different accounts, different users, to be weakly independent. That means that the order in which they are processed doesn't matter. And then we just throw them in parallel, broadcast them to all the validators. And the validators simply take each of them, settles, each of them, settles. It's a bit more complicated than that, but imagine that they just receive and save the transaction and modify the state, because there are mathematical arguments why the order doesn't matter. They will get the same state eventually. So that's what happens. And this is a well-known principle in distributed systems and concurrent programming. It was inspired by many theoretical models. The actor model, for example, of computing, promotes and pushes hard this principle of true concurrency. And we realized that we can have this amazing principle that gives maximum horizontal scalability, which is the maximum performance that you can get. We can have that for Web3, but we have to think a bit out of the box, get out of the blockchain box.
Yeah, absolutely. We spoke a lot last time about the K framework. I'm keen to understand what role does the K framework and also like verified system level logic play in achieving this? You know, how is it different from existing layer 1 or layer 2 architectures?
So they are orthogonal problems. So the K framework and all we can do with the K framework, and FastSet and all we can do with FastSet, they are completely orthogonal. So let me explain. So the K framework is what allows us to have this universal framework for verifiable computing. Any computation in any programming language, thanks to the K framework, gets a proof, a very succinct proof that confirms that computation. Okay? And all this can be done off-chain. Now imagine that you have like millions and millions and millions of applications computing things off-chain which come with proofs. Okay? So you have a claim and a proof, a claim and a proof, a claim and a proof, but you have millions of them per second. Okay? So that's what the K framework does, and we solve that problem. The K framework is, well established. I invented it in 2003. Actually, I invented it in 2001. Really, the first idea when I was at NASA as a research scientist, and then I continued to develop in my lab at the University of Illinois Urbana-Champaign, where I'm also a professor. And so that was solved. But now the question is, how can we settle all these computations at the speed of light? Because everything else is too slow.
Yeah.
Okay. So once we do lots of computations off-chain, then we want to settle them very, very fast. And that's what FastSet does. FastSet simply takes all these computations and settles them at the speed of light.
Interesting.
So they are completely orthogonal. The K framework and the verifiable computing generated by the K framework can be used also with L1s and L2s, with blockchains. And actually, we've done that. At East Denver, we had a workshop where we showed how to bring all programming languages to blockchain. You can plug and play your programming language. We called it BYOL, bring your own language. So you can plug and play your programming language. No problem. That works perfectly.
Yeah.
The problem, though, is the blockchain itself. So we realized that we can do exactly the same thing, have all the benefits without a blockchain, but having this new structure, new Web3 structure that we call SET. And FastSet is the protocol that makes it really fast.
Interesting. So what are the real world implications of hitting these metrics, for developers, users? enterprises and I suppose the broader Web3 ecosystem in general?
I think we don't know yet where the limit is. What the sky is the limit. But what we know for sure is that everybody who uses blockchains suffers from this scalability problem. Okay, things are too slow on blockchains. Actually, that's one of the reasons why institutions are not eager to join the Web3 movement because they think Web3 equals blockchains. Blockchains are slow. So I think this will unleash a new wave of interest and applications to be deployed in Web3. So developers will naturally be interested in providing these applications, but I think the really, really big implications are mostly with users, retail, and institutions, because there is clearly a big push to bring digital assets on chain. We don't like the on chain term. We say on set now, but the idea is to bring them to Web3. And the problem is performance. Now imagine that you live in a world where you can have your own digital assets in your own account, which still is as secure as on blockchains, protected by your private key that only you own and nobody else, and unless you want to. And now suppose that you have thousands of such assets and you can transfer them instantaneously anywhere, to any program, to any person. Then what do you need more, right? So that's the fundamental infrastructure that we need for Web3. Then additionally, you can now bring all programming languages. So developers can join Web3 with their favorite programming language. They no longer have to learn all these crappy programming languages that unfortunately were invented long ago by some non-professionals, I would say, programming language experts, and now we are stuck with them in Web3. So, but there are also very good languages, like Move. Move is a good language, well designed by professionals. But most of the other languages are not. And now developers can bring their own languages. But I think the really, really big fish here in the short term will be the retail and institutions. Institutions because they provide infrastructure for light speed transfers of digital assets, and retail because I don't know about others, but when I joined blockchain was because of simply transferring money, tokens from me to my mother, for example. I paid $60 from the United States to transfer money to my mother in Romania. For a $2,000 transfer, I had to pay $60, right? So that's 3%. Yep. I mean, even if you transfer 1,000, you pay 60 because each bank has to get its cut, right? And it took 5 days end to end. That is ridiculous, right? So with blockchains, at least took 10 minutes. So yeah, but that shouldn't take that long. It should be instantaneous. So FastSet will give us an instantaneous, imagine an instantaneous Bitcoin, but with all tokens and NFTs and SFTs, semi-fungible tokens, and all kind of digital assets. So I think retail and institutions will be the first who will really
see the benefits.
And then developers will come because they have all the languages.
Yeah, I think that's great. To bring your own language. I really like that element to it. You've mentioned a public testnet is coming later this year. What will this include, and what can developers expect to experiment with?
So we are going to have a pre-testnet very soon, in 2 weeks or so, and then a testnet later in October, September, October. The first version in 2 weeks, and I strongly encourage everybody to go and try it, go to our website and give it a try, will just show this capability of doing 100,000 TPS at less than 100 milliseconds latency that nobody else can do or can do consistently. So we are going to have a website where you can come and you can get your account. You can, start sending assets. You'll get a faucet, you get some tokens, and you start sending them around, and then you'll see how many. There'll be also a game that will be a surprise, a fun game where you can click a button very fast, and all those will be transactions that will be submitted and settled, and want the community to achieve together 100,000 TPS. So everybody will see the new performance of Web3. That will be now, very, very soon. Probably it will be already there by the time you publish this. I don't know. We'll see. But later in September, October, we also want to add 1 or 2 programming languages for smart contracts. One other feature that will happen also September, October is that this network is not a chain, it's a network, a FastSet network, decentralized network, verifiable, same like blockchains, but not a blockchain, will also be connected with major L1s and L2s. In other words, all the liquidity on all of these chains, L1s and L2s, is unlocked for applications they deploy on FastSet. And the other way around, whatever claims approved and settled on FastSet can be sent to smart contracts on the different chains, so that developers can write ingenious applications where some things happen on Ethereum and some other things happen on FastSet. For example, you may have an AI agent that does all the transactions on FastSet because it's super fast and very cheap, but you top up the account of that agent on Ethereum, let's say, or on Solana or Avalanche.
Will this testnet support custom contract deployment, and what tooling or infrastructure is available for builders on day one?
So on day one, we'll definitely have EVM available and the capability to deploy blockchains on top of FastSet, like layer 2s, if you want. So FastSet is like a layer 1, but it's really not a blockchain. It's a layer 1, which is not a blockchain, but you can deploy blockchains on top of it as layer 2s. So that capability will be there. And also arbitrary EVM programming. So we want the most common programming language to be supported from day one. And then shortly after, other languages.
Amazing. Are you seeing any early signs of developer adoption or interest from enterprise use cases? Are there any partnerships or pilots underway?
Yes. So there is a lot of interest when it's interesting. There are 2 different categories of interest that we see in partners and collaborators we approach. One is with respect to performance, right? So when people hear 100,000 TPS, less than 100 milliseconds, first of all, they don't believe us. Then we show them all the evidence, the papers and everything, and they say, wow, that is the next step. Then they say, we are very interested in that. In particular, the AI agentic companies. We are discussing, I cannot disclose all the names now because we want to announce them at the right time, but we're discussing with several AI agentic companies. And the AI agents communicate with each other. They have protocols on how they communicate. They pay each other. So all those need a very fast network to send micropayments, and also obviously very cheap because you don't want to pay $1 for 0.1 cent transfer. So that's one category, and they are interested in performance. And then there is another category which is interested in bringing all programming languages and applications from the Web2 world, like games, for example, or high-speed trading platforms. So we have more than 20 partnerships, MOUs, motion of understandings, that will actually integrate with different partners, more than 20 partners at this point, and we'll integrate with them at launch. And the launch should be sometime very late this year or early next year. And all these institutions and partners will be disclosed at that point.
Exciting times ahead as well. What does scaling beyond 100,000 TPS mean? Is this the ceiling or just the beginning? How does FastSet, remain decentralized and secure at this speed?
Very, very good question. So first of all, 100,000 TPS is just the beginning. Took us only a few weeks to get a first prototype that can support 100,000 TPS. The paper is called FastSet. Anybody interested, go to our webpage and go to the white paper to see the FastSet paper. The paper shows mathematically that there is no limit, no ceiling. So it's horizontally scalable. If we need more TPS, we add more validators to the network. Okay, because each, and that now also going to the second part of your question, how can we remain decentralized and secure at this speed? So the way FastSet works is that each claim, let's say a payment, right? Each transaction, we don't call them transactions because they can be arbitrary claims that come with proofs. They are more general than transactions. So any claim that comes with a proof is broadcast to a set of validators, a committee of validators, who have to check the proof and sign. Then the signatures are aggregated together into one signature using well-known and well-established cryptographic methods. And that aggregated signature is the proof now that the claim is true. And now that certificate of correctness is now broadcast to all validators. And the validators now modify their state accordingly. Okay? And they update their state. So if you're a first year, say, college student in computer science, you realize immediately that this is horizontally scalable. There is no ceiling here, right? Because you can have as many committees as needed based on how many claims are thrown at the network. And then you just broadcast messages to validators. Of course, everybody will have to have a fast internet. Everybody will have to have some memory to queue all this. But there is essentially no theoretical limit at how many claims you can settle per second. So just the beginning. And is it decentralized? Of course. So we hope to have like 1 million validators very soon. We are going to have a node sale at some point, and we want to have a lot of validators because their job is really not that hard. It's actually simpler than on Ethereum, let's say. And Ethereum already has more than 1 million validators. Okay, so that is decentralized. Highly decentralized network. Everything will be verifiable. Of course, will be verifiable. All claims come with proofs. Actually, more verifiable than on L1s and especially on L2s these days. Right? So everything will be verifiable. Everything will be decentralized. Secure? Of course, it will be secure because each claim will be signed by the owner using a private key. So from a user's perspective, you'll see and feel your account same like on blockchains. You see a private key, which is your account. You have a public key, which is your account, a private key that controls it. You see your assets, and you can generate transactions and claims that you sign. Same like a blockchain. What's different is what's under the hood. Same like with a car, right? You can have a diesel engine or an electric engine. As a user, you don't really see the difference. You quickly adapt from one to another. Same interface, 4 wheels, right? Driving wheel, you drive the car, right? No problem, it's electric or not. Same here. It will be the same, but the speed will be unmatched by blockchains.
Yeah, I think something important for us to discuss is a lot of chains chase speed but compromise on principles. How does FastSet maintain trust, assumptions, and modularity while achieving, this level of performance?
So chains have to take shortcuts to be really, really fast. We know the blockchain trilemma. You cannot have at the same time scalability, decentralization, and security and correctness. That is the trilemma of the blockchains, not the trilemma of Web3. So they have to compromise on one of these three, right? Not thanks to, but due to the trilemma, you cannot have all three of them. But once you step out of that box, that everything must be a blockchain in Web3, then you realize that the trilemma is not applicable anymore. And how can we maintain the trust assumptions? Exactly the same way. Everything is verifiable, actually even better. Think about it. Does the total order is what matters on in Web3, or the fact that it's verifiable and true? So if you make a payment, what matters? That your payment came before mine or after mine? Or let's maybe not payment, let's take a vote. Suppose that we both vote. Okay, does it
Yeah.
matter if I vote before you or you vote before me? No. All it
No.
matters is that we vote before the deadline. That's it.
Mhm.
And do you need a blockchain for that? Of course not. It doesn't matter if a validator receives your vote first and then mine, or mine first and yours after. And as a matter of fact, if you have 1 million validators, it's quite okay that half of them will receive yours first, and then mine, or the other way around, because in the end they will increment the counter twice, the counter of votes twice anyway. So that's how you get performance. You get performance because of the right architecture, which is not a chain. It's a set. You just set everything. And then everything is same like on blockchains, or even better, right? In the sense that everything is verifiable, everything is comes with proofs. So you don't lose anything from blockchains. You gain performance by actually enhancing the architecture.
Yeah. Amazing. Looking ahead, this has been a huge milestone for you guys already this year, and in a short space of time, especially from when we last spoke. But what's on the roadmap for Pi Squared in Q4 and the rest of 2025? Then where does this technology fit in the evolving Web3 stack?
So, with respect to the first question, before the end of 25, we'd like to TG, to have a testnet and demonstrate all the capabilities of the new approach to Web3, and then launch our token. And then 6 months later, so early summer, late spring 26, we want to launch our mainnet. One thing that we'll do in the meanwhile is also this year is to launch an AI agent for arbitrage. Why arbitrage? Because when you do arbitrage, first of all, it's very boring for humans. It makes sense to do it using AI and bots. Second, you do lots of small transactions where you need speed and low costs. And this is what FastSet offers best. And we use this agent as a way to illustrate the capabilities of the network. This agent would not operate well, for example, on Ethereum, because everything would be too slow and too expensive, even on faster blockchains. So that's the plan. The plan is to have an agent and a testnet launched before the end of this year, and then TGE also at the end of the year or early next year, and then 6 months later, tops, to have the launch of our mainnet.
Amazing.
And your second question was, there are two questions.
Yeah. So where does this technology fit, in the evolving Web3 stack?
Well, so I think, I believe strongly that it will revolutionize the Web3 field as we know it, the Web3 revolution. Web3 is a revolution in my view, where people finally started to understand that they own their assets and not Google, not Facebook, not Citibank. They are ours, not universities, right? Universities own our degrees. It's unbelievable. If I want to prove that I have a PhD, I have a hard time actually. I have to go to University of California, and to convince them, I have to go through some, pain. Why should they have my PhD? That's ridiculous. It's mine. So people really believe in the Web3. I'm a firm believer in Web3 as the future of humanity. And the reason I found it, I found it Pi Squared, and we developed FastSet and everything we talked about, is because blockchains do not give the right answer to this Web3 quest, and we need a better infrastructure. And we tried to build the entire stack end to end, starting with programming languages, correctness of executions, defragmentation based on mathematical principles, And we ended up with having to reinvent the fundamental consensus protocol, because the existing consensus protocol of blockchains enforces total ordering, and it is slow, not scalable by design. Correct, but not scalable. While we came up with a protocol, it's called weak consensus, the weak consensus protocol, which is both correct and scalable. The only difference is that temporarily, validators may have different states, but they eventually converge. And that's what's important, and not the fact that at every single step, all computers in the network have exactly the same state. That's not a requirement. That's, like in your car. I bring again the metaphor with the car. Do you care if you have a gasoline engine, a diesel engine, or an electric engine? Maybe, but not for too long. Try to take whichever is the best, cheapest, fastest.
Yeah, of course. Awesome stuff, Grigore. Thank you so much once again for joining us, sharing this exciting progress that Pi Square has made with FastSet. So yeah, appreciate you coming on once again.
Thank you so much. I hope you'll use our pre-testnet in 2 weeks from now.
Yeah, absolutely. If you're a builder looking to experiment with lightning fast, secure blockchain infrastructure, do keep an eye out on Pi Squared this year and visit their website www.pi2.network and follow Grigore and the team on X at pi_squared_pi2. Thanks so much, and we'll see you next time.
Thank you, Aaron. Bye.